Salutations! You are tuned into our webinar, making it easier to manage comms via multiple satcom services from our sponsors, XipLink. Our guest speakers today from XipLink are CEO Jack Waters and SVP of Marketing, Sar Smith-Reddy. If you have any questions, do leave them in the Q&A section for answering later on. And here's Carl Jeffrey from Digital Ship to explain more.
So we're going to talk today about how to make it easier to manage ship-shore communications through multiple satellite services at once, and how we can make use of cloud services to route the traffic. And it looks like managing a combination of satellite communication services is going to be a big part of the task of shipping company IT managers from now on. And as you all know, there's services available with different data rates and reliabilities and costs and delays and packet losses and coverage areas. But if you stitch together a service with low cost and low reliability, together with a service with a high cost and high reliability, in theory, you can get both low cost and high reliability. But you can only do it if you've got a system that's manageable. So to make that easier, we can route data through a cloud service when it goes from the shore to the ship. And the cloud service can route different types of communications through the most appropriate network. When the data goes from ship to shore, we can have a box on board that routes the communications, getting its instructions from the cloud. The technical term for this is a software-defined wide area network, or SD-WAN. And having this cloud service also makes it easier to open up communications to shore in a new part of the world. It can be installed very quickly and you pay by the month, so there's no big investments in software or setup. And we're going to hear today from XipLink. They're a company that offers this cloud service. They've been in the maritime sector for a number of years. Their software is used by some satellite communication companies and some provide it under their own name. They're going to give a case study of how their system is used by a satellite service provider and also by a shipping company. Our speakers today are Jack Waters, the CEO, and Sar Smith-Reddy, the Senior Vice President of Marketing. Jack has had leadership roles in network communication companies for 30 years, particularly in sales. He was formerly head of sales at iDirect, and he's joining us from Philadelphia. And Sar Smith has been working in technical marketing for over 20 years. He's also formerly at iDirect, and he's joining us from Hyderabad in India. So I'd like to invite Jack to start his talk.
Well, thank you, Carl, and thanks everyone for joining. We look forward to adding some incremental value to everyone today. Today we will talk a little bit about the changing landscape in SATCOM, which I'm sure most of you are familiar with. And we will also give you a little bit of background on this new ZipNet service that we'll chat about in a second. But maybe more importantly, toward the end, we'll talk about real life scenarios and throughputs and some testing that we've accomplished that might be very informative for you. And as Carl mentioned in the introduction, why consider an SD-WAN solution for multi-orbit? And the reason is exactly as he stated. We can end up getting a better service for lower total cost by combining different orbits and different types of connections. And in addition to the SATCOM connections, of course, we have the 4G data and the 5G data as well. And so if you go around the circle, and I won't mention each one, but some of the key items here are enabling application performance. So as we all know in maritime, connectivity is the big question. Am I going to be connected all the time? Are there going to be outages? And as time goes on, we get better and better connectivity at higher bandwidth. And that's what's happening exactly right now. We're going to take that one step further and allow multiple connections to either, MEO geos and cellular data all at the same time, as opposed to switching. And that will allow nonstop communications. And that's absolutely necessary if you're accessing corporate cloud services and video conferencing and Teams meetings and so forth. And so that's a driver. Okay, and then as you all know, right, all the different orbits have different characteristics. GEO is very stable and we know what to look for, but it has higher latency. LEOs have enabled a lower cost service at low latency, but then there's inter-satellite handoffs and interruptions in the bandwidth. And we won't get into how we do this quite yet until we get to SASMIS section, but we can show you how ZipNet can mitigate the handovers and keep performance operating throughout the network. And of course, there's MEOs for even higher capacity requirements. There'll be more MEOs launched in the next few years. And cellular data, of course, once you get near shore, then you can access some of the LTE services, and we can accommodate that in this multi-connectivity architecture of ZipNet. Okay, once you start looking at a SD-WAN solution, there's several things to look for. Obviously, most SD-WAN solutions have multiple path capability and some element of traffic steering along with that to allow you to build policies on what's the primary connection, what's the connection look like when there's failures in the network, and so forth. And of course, you'd like to add more capability as the cost goes down, so the whole solution has to be very scalable. So when you first buy into it, it might be relatively lower speed, but then you might have the ability to scale to much higher data rates. So you'd want to be looking out for that. You'd want to be testing some application capability, tying into some of your cloud services that you use frequently, and make sure that the application performance is high during those applications, and some ability to monitor those during the process. And the number one thing in the bottom left corner here is the user experience, which is very hard to measure, but we have some measuring statistics in our system that would show you exactly what kind of user experience you're getting versus a non-SD-WAN or a non-optimized solution. And then, of course, when you add it all together, what's the total cost of ownership? And we'll talk a little bit about that in a minute. Okay, so what is ZipNet? XipLink is a company that's been around for 17 years in the WAN optimization space, very focused on satcom. And over the last 2 years or so, we've created a cloud product to make a couple of things happen. One is to allow aggregation of multiple connections over satellite that you can see on the left side here, where you might have an edge device on a ship or a ferry or some similar vessel. And you might have multiple terminations. You might have bought a Starlink. You might have bought a geo service from one of the integrators. You might even have access to a microwave network. You can combine all those together and have them all available operational for one single bandwidth pool, which is quite different than the past, which was I switched between them one at a time, and therefore had a delay, and therefore the traffic patterns change quite radically when you change from one to the other. Now what we can do is have them all active, and then the traffic steering policies, the user policies, if you will, can determine what traffic goes on what link, and then if that link fails, what they're to do on the secondary and third link if there's a failure in that particular device. That goes into the ZipNet cloud. That's where all the development's been done, and that's one of the main differentiators of this service is you don't necessarily buy any software. You don't do any training of your operations. As Carl mentioned, it's a very easy way, low-cost way on a monthly service basis to get into the SD-WAN business with no investment on the data center side. One of the keys to cloud service of any kind is where do I terminate? And in our case, what we've done is we've built these points of presence or POPs around the world. And in red are the ones that are active right this minute in Europe and North America primarily. They're typically located at the major data centers or the earth station areas where the new LEOs are going in to minimize the latency between the LEO handoff, the internet, and our connections. And then we have in blue some of the new POPs that will be deployed. One of the nice things about a cloud service is we can deploy a POP literally in a couple of hours or less. Without shipping anything. We have a partnership with a web services company that we can co-locate and literally turn on service in a new area very, very rapidly. So that's one of the key benefits. And then as the developing nations develop more service and better capability for the internet, then we would turn those on into this network. What does it look like? It's a very simple service to buy into. There's one of two edge devices you would put on a vessel. One has an aggregate called the XH10, an aggregate capability up to 250 megabits. So 2 Starlinks or a Starlink, a Geo, and a cellular would aggregate to about 250 megabits. And then if you have larger requirements, we have a larger device that will go up to 1 gigabit per second. And the way we profile the service is that's a burst rate. So you can go up to either 250 megabits or 1 gigabit per second in a non-blocking sort of way and get the highest throughput. And that's the highest in the industry. So you can see the TCP session count is something that most of you probably don't track, but it's a very safe number for the applications that are listed here. And then it's a very low profile device to put into a remote vessel. On the bottom are the actual service packages. Okay, so you buy this device, you put it on the edge. There's nothing to buy on the cloud side of this, right? It's already in and it's included in your monthly service fee. So there's no hub side investment, as some people might call it. And there's 3 levels of service. We're looking to maybe add some more service later, but right now, one caps out at 250 megabits, 500 megabits, and 1 gigabit per second. You can see that we can aggregate up to 24 types of connections. A typical application would have anywhere from 3 to 9 kind of connections, but we can actually connect up to 24 devices at once. And then there's no data caps with our system, so you don't have to worry about that. In fact, we will monitor your data caps on your services that are tied into this system so that you can avoid going over, or you can set a policy if you do go over how much to use and so forth. One of the key features in this service, in the ZipNet service, is the ability for the end user to see what's going on. So when you combine all these connections in one large bandwidth pool, the danger is that the logical connections get lost, that you can't actually see the individual connections. So we've created a nice application, a ZipNet app, that will do several things. It will monitor the health of each link. It will tell you which links are being used the most and which ones are getting the highest performance. You can see in the middle graph, it will actually show you the increase in performance from the WAN optimization we include in the service. So Microsoft 365, for example, was improved by 132% in this particular case. And then you have a speed index that can tell you, all right, on average, how am I doing in terms of total capacity? And then on the right, you can see, okay, if I go on an individual link basis, how's my Starlink doing? How's my Geo connection doing, and so forth? And you can see the relative statistics. So typically this would be held by the captain or the IT team on the device on the remote side and give them the information they want. We also have all this information in the cloud central. So our channel partner that's selling the ZipNet service has an even broader view of the optimizations on the network. And last but not least for me, and then Sasmith will take over, this is a typical deployment for us. In this case, it's a ferry. The ferry has a Starlink terminal. They had a traditional Geo service for a few megabits per second. And then they've augmented that with Starlink, so they can burst up to 120 to 200 megabits per second, depending on what the Starlink availability is. And the 5G and LTE services they get within 10 kilometers or so of shore. Then there's the passenger LAN and then the internal LAN, 2 different LANs typically on these ships. They all come into the edge device. That goes over the various satellite connections, terminating in those different teleports, which are then routed to the ZipNet cloud, optimized, and then processed back to the user source. So one of the key things we do that's different than everybody else is we do both bonding and balancing. So if we have multiple Starlinks or multiple low latency devices, we can bond those together in a pool. And if they're wildly different latencies, like between Geo and Starlink, we can balance the traffic and understand exactly what traffic flow is going over the links so we can bond those properly. So it's a truly shared bandwidth capability. And the benefit to the end user, of course, is they get a lot more capacity for less money.
So thank you, Jack. I'll cover some of the service test results. We'll show you typical performance for two different customers, and it'll also show you how these applications worked for these customers. So this is customer one, where this is a maritime customer. They had four separate links, or four separate services. Eutelsat Geo service, an iDirect service, OneWeb LEO. They had two of those links, terminals on the vessel, and an LTE service when they got close to shore. And these were the they had predefined the priorities of these, how the applications would be routed, which links they would use to ensure based on their corporate policy on how they wanted the bandwidth to be used, how the application performance, etc. So, for example, here the voice over IP that they had from ship to shore, the default link was Geo as long as it was available. If it's not available, then you switch over to the LTE if that is available and they're close to shore. Otherwise, balance it across any one of the LEO links that's available. And the second example here is the Teams video call, where priority was the default was LEO 1, then LEO 2 was the first failover, so on and so forth. And the file transfer they used for this particular customer, they wanted the Geo as a default link for their file transfer. And then if that Geo link was not available, then balance or use any one of the links that's available. And so on and so forth, right? So they defined these priorities on how they wanted their services to work at the remote location or on the vessel. The first one I'll show you, this is a real capture of how a voice call was performing. In this case, as they had defined that the call would go over a Geo link by default, you can see that the call was set up, was going over the Eutelsat Geo link. And as the call was going over, they initiated a failure condition by disconnecting that Geo link. And you can see that the system, the ZipNet real-time link intelligence that built into ZipNet is observing these links on a real-time basis and then initiates a failover of this call over to the LTE link because that link was available at that time. And then again, initiated a failure or simulated a failure of the LTE by disconnecting it. And the call would automatically or has automatically switched over to OneWeb 2 link here. And once the primary link is restored, the call would go back automatically to the primary link. One of the key things here is that the call was never interrupted. So the end user didn't even realize or didn't know that it was failing through these different links. So that is the real benefit of the solution. And this is actually enabled by multiple technologies that are built into ZipNet service. The traffic steering, the automatic traffic steering capability, the priorities that you would set, the QoS, which you can define on a per link basis, and also the real-time link intelligence that's feeding the quality of the link information to these other algorithms that are running on the ZipNet service or the edge device. So this provides a very good user experience since there's no user interruption of the call at all, regardless of which link that particular call is going over. The second one here is a file transfer. A couple of things. Again, the priorities were as defined. The call would the file transfer would get initiated on the Geo, and then in case of failure, then it was set to use any one of the LEO links. And you can see here that the real-time link intelligence provided or determined that the OneWeb 2 was a better link, so it switched over to OneWeb 2, and then and when a short duration or time frame, it determined that the LEO 1 was better, so it switched back to LEO 1. And it continued. One of the key things also to observe here is that because of the acceleration or the skips algorithms that are built into the ZipNet edge device, you utilize the link to its full capacity. The skips algorithm also ensures that you got the fast start and fast recovery capability, and also the rate control algorithms mitigate the effects of loss whenever there's loss on these LEO links when the satellite is being handed over, or the service is being handed over to a second LEO satellite that is rising or setting, right? And then you initiate, they initiated a failover by disconnecting the OneWeb one link, and it failed over to the second OneWeb here. And then the transfer completed. But since the geo was not yet connected up or not available, when they initiated a new transfer, it started on OneWeb 2, and then once the geo was available, it automatically switched over to the geo link as that was defined as a primary. And throughout this whole failovers and transfer, and steering or traffic steering that's going to other links, the file transfer is never interrupted. So there are two key benefits here to the end user. They do not actually see that there was a failure of a link or the transfer was changed or moved to another link. But also you're utilizing your capacity to the best possible extent, because you're not doing many retransmissions where you would typically have, in a session fails, you have to restart the whole transfer again. So all of that optimization is built into the ZipNet Edge device. So the user experience is extremely good because it's uninterrupted and you utilize the capacity to the maximum possible extent. So that was a customer one test that were done. And then we have a customer two who also had 4 different services or links, actually, the wider network links. This is a maritime service provider. They had 2 geo links and 2 LEO links in this case, all different services, Inmarsat Geo, Intelsat Geo, OneWeb LEO, and Starlink LEO. And as you would expect, typical maritime services, voice is a key for most of those users, and also the file transfers and video calls. And in this particular case, the service provider was defining the OneWeb as a primary link for voice, Starlink as the first priority in case OneWeb was not available, and then the Inmarsat Geo. Again, keeping in mind in this case that what is their lowest cost service, so that you're not hit with a big bill, right? And then the file transfer, they were using Inmarsat for that, and then in case Inmarsat was not available, they wanted to balance the load across the OneWeb and Starlink. And then for any other traffic, they wanted to use both balancing and bonding as defined by their end customer. And I'll explain the difference between balancing and bonding as we go through the test cases in the next few slides here. The file transfer is similar to what you saw earlier with the first customer, but this started with Geo here because that was a link that was defined as high priority. And then once they simulated a failure by disconnecting that, it switched over to OneWeb, as that's what the real-time link intelligence in the ZipNet device determined. And the transfer completed, so they reinitiated it, and then they simulated a failure by disconnecting OneWeb, and it switched over to Starlink. And then once the Inmarsat terminal was reestablished, or connection was reestablished, the SD-WAN service automatically moved the file transfer over to the Inmarsat. Again, the thing to observe here is that you're utilizing the maximum speed that's available on these links. You can see here that it was going at about 80 megabits per second on OneWeb, and approximately similar to Starlink, and Inmarsat being in the megabits per second. You can see that it was utilizing the higher capacity there, or the capacity that's available to it. Again, no interruption while they were doing these, while the application was being switched between these links. The next one is a traffic balancing or session balancing across the two Leo links. And in this particular case, as sessions come up, let's say they have multiple browsers or multiple users on this vessel, and each one has are browsing different things. They have multiple sessions. These sessions are balanced across the links that are defined in the priorities. And you can, in this particular case, they did not want the general internet traffic going over Inmarsat, just over the Leo links, and the user applications were balanced across this. And you can also see here that at some point the Starlink service was not available during this time frame for whatever reason, and all the sessions got automatically moved over to the OneWeb service. And once Starlink was reestablished, connectivity was reestablished, then again the service was balanced across. So the key, one of the things that the ZipNet Edge device does is it not only balances sessions as they are initiated across the links, it also rebalances the traffic across these available links on a per second basis. It's monitoring, it's looking at the link quality for available bandwidth, for loss percentage, for delay, etc., and then balancing these sessions around the available links based on their link quality. That's very, very important because that allows the end user to utilize their links to the best possible extent. In some of the services that are available, once a session is set up on a particular link, it stays on that link till it's terminated. In the case of ZipNet, it actually automatically moves these sessions based on the actual performance of those links. Very, very important from a cost perspective, and also ensuring that you're getting the maximum performance when you have these links. The next one is bonding. In case of bonding, whenever you need a higher capacity than provided on an individual link basis. For example, let's say at a particular location, you're getting about 80 megabits on OneWeb, and let's say about 60 megabits on Starlink, but you want to bond those two to give 100 megabits to your end application. Typically that would be either video or some sort of a backup that's happening, etc. The ZipNet Edge device can provide that bonding. It can bond a single application across two links so that you're getting a higher capacity than an individual link can provide. And in this particular case here, you can see that the OneWeb is actually providing a low, some capacity here, about 40 megabits on OneWeb and close to 90 megabits on the Starlink. Excuse me. So that capacity was bonded to give an effective, about 130 megabits to the end application itself. So depending on what is required on the vessel and what applications you have, you can choose to configure either bonding, balancing, or both, and apply it to specific applications. You could say, for my video, I want it bonded. For my internet, I want it balanced. And so this is very important because, again, it goes back to enabling your higher speed applications while also at the same time utilizing your capacity to the best possible extent. So you're getting what you paid for, right? You're getting the full service. Excuse me. So those were the two use cases, or what we real deployments out there where they have been tested, and you can see how the applications were performing and how those links were being used. Now, the key technologies that are in the ZipNet service, there are many. I'll only cover a few here that are important. The first is link balancing and bonding. We just went over an example of that, where traffic can be balanced by session or stream by stream across the available links, or bond them across multiple links to provide higher capacity to a single application or a stream. So that's one key technology. And the second one is the ability to accelerate and optimize. It's very important. Most of you know that acceleration is important for geolinks, but it's also useful for LEO services when there's a higher delay, etc. Typically, any round-trip delay greater than 80 milliseconds, it is proven. I mean, you can test it for yourself if you wish, that having acceleration gives you a higher throughput. So when in the ZipNet Edge device with the 6 skips TP algorithms that are implemented, we can not only accelerate, but also provide things such as rate control or congestion avoidance so that you get the best possible utilization of those links and maximum throughput because of the built-in acceleration. The other one is maximizing traffic flow. That again comes the benefit of ZipNet having the skips algorithms. Because of that, you're getting a higher average throughput because the real-time link intelligence that's built into ZipNet is looking at the links, looking at the loss percentage, and then automatically ensuring that the right amount of traffic is sent over the links, mitigating the effects of loss. So you get maximum traffic flow. And then traffic steering, it's intelligent traffic steering because it steers based on not only priorities, but also based on link conditions so that your applications, especially if you have critical applications that you need to ensure that they're available all the time or have the highest possible availability, that is possible because of the intelligent traffic steering that's built into ZipNet. We also have what's called traffic spreading that's available. This ensures that a critical application is sent across multiple links to avoid any sort of loss. For example, if it's a voice, you want to send a control channel over multiple links, whereas the voice payload can go over a single link. So you could utilize the robustness of Geo to send just the trickle control traffic so that your connections are not, or your voice calls are not disconnected. But very, very useful when, especially in a voice scenario, or in some cases, if it's a highly critical data application that you need to ensure that it goes through. So that's built in. There's also application-aware QoS and firewall. So we got DPI that's built into the service. It's a layer 7 and beyond. For example, if you have a Teams deployment, you can not only look at that as a Teams application, but also see if it's a video on Teams or a chat on Teams, and then assign the right QoS or assign the right traffic to that. And definitely the redundancy, service redundancy, because you have multiple links and service overflow. And this is very useful, especially when you want to control your costs over a certain link. If it's a high cost service, you may not want to utilize that or put traffic on that service unless you really need it, or if it's volume-based service, etc. And then you can set up those priorities and rules so that traffic is only sent over those links only when there's an overflow condition or if the primary link has hit certain thresholds. Again, all of this is to ensure not only user experience, but also looking at the total cost of ownership. So to summarize, ZipNet service not only provides you the gigabit performance, as Jack mentioned, you can go up to 1 gigabit today, aggregated across any one of these links. It doesn't matter what the latency of the link is or the link quality. The built-in real-time link intelligence ensures that the right application performance is there and the bandwidth is used properly. We also have 95% utilization across these links. The overhead of the ZipNet SD-WAN is very, very low. So you're utilizing the capacity to close to 95%. Again, you're getting what you pay for on these links. It does speed up service because it's got the built-in acceleration and other optimization techniques. And overall, it's flexible because you can not only get service, or, especially in the maritime world, as you're going around the globe, you can get service as you're going across, and you can also from the app, the ZipNet app that Jack mentioned earlier, You can also choose the closest POP that you are there so that you're ensuring that your latency is the lowest. And we also allow you to suspend service. So it's seasonal. In the maritime world, a lot of services are seasonal. And you can suspend service and then reinitiate the service once the season starts again. So it gives you the flexibility, which obviously the cost effectiveness and the gigabit high performance. So that's the end of the presentation. We can take Q&A, Carl.
Wow. Well, thank you very much. So we'll go to the Q&A part of the presentation. If you want to put any questions in the Q&A box, I can see we've got a couple there already. Yeah, if you want to stop slide sharing, and Jack, if you want to bring the camera on. And so, yeah, we've got two questions to start off with. So, Wei Ho, I'm just looking you up on LinkedIn. I can see you're in Melbourne, IT manager of WorldLink Communications. So first question is the POP going to be dynamically switched depending on the actual location of the ship? And the second question, I think you probably answered this after you were saying, but so are you going to deduplicate or other compression techniques that do the WAN optimization? Should we take both of those together? Or?
Yeah, I can take both. The first one, the POP, we do not do dynamic switching today. We could definitely do that, but we provide you the ability to select the POP on the vessel depending on what you want to do. So it's definitely possible today by the end user itself, by the IT person on the ship or the captain on the ship. You don't have to call in or get that initiated from the land side. That can be done. Dynamic switching, we're considering that, but we have not been requested that yet. But definitely we can consider that if it becomes useful or makes sense. But the second one, can ZipNet do WAN optimization like packet dedupe or other compression techniques? So ZipNet uses ZipOS, and these techniques are available. But the benefits of, for example, byte caching or dedupe is available, but it is not enabled today, primarily because with most of the traffic being encrypted, the benefits of this have gone down tremendously. So we have not enabled dedupe, but the other compression techniques are all available. We got header compression, we got packet coalescing. You can do a header compression at not only on the TCP, UDP, but also if you have GTP all the way down the GTP stack, so which gives you a significant benefit. And payload compression, if enabled and if it has enough compute power, will be there. So the WAN optimization techniques are built in, and these work hand in hand with not only the QoS, but also acceleration, etc.
The TCP/IP is quite communications heavy. I think you can take about a lot of communications out if you wanted to. Yeah.
So typically, all the what you're known from the past, the XipLink optimization, they're all available, the compression, etc.
Oh, very good. So coming to England now, so John Joyce is the network administrator for PGS. So they run a seismic ship. So I imagine they want to love to have great ways to send huge data files rather than sending it on tape. But he's saying, can I determine the landing country or Earth station for Starlink? So I want to minimize the latency. Is there any control on the data landing? I guess Starlink doesn't give you any control on where the Earth station is. But I guess once it goes to Starlink, it's up to them where it comes ashore, is it? Or is it?
Yeah, that's right. I mean, I can answer that. We've purposely placed our POPs near some of the Starlink and OneWeb terminations for that reason. But yeah, I mean, Starlink doesn't give you exactly access into their closed system. So we're kind of reliant on them terminating their traffic into their Earth stations, and then we pick it up from there. So there is a bit of latency between that point where the termination is for, say, Starlink or OneWeb and our POP, but we purposely place them close.
When you imagine Starlink would route it to the most appropriate place anyway, would they? So maybe not.
And if I can add to that, Jack, because we have the built-in skips acceleration algorithm, even that we mitigate the effects of that latency as well when it comes, because the ZipNet service from the edge to the ZipNet cloud, wherever the POP is, the effects of the latency are mitigated by the acceleration built in. And
Oh,
you can always choose to also switch the POP from the ship if required, right? If you feel a POP is closer to you, because the app actually does show you the closest POP that's available to you and which POP you are currently connected to. So you can, based on that, you can just click on it and it automatically switches you to that POP.
well, I'm quite surprised that latency on the terrestrial side is an issue. I thought the latency was all on the satellite part of it, but yeah.
It is for some of these depending on where the landing site is, and the country it's landing to and their backhaul. So we do see it sometimes, but overall the application performance is not really affected because of the built-in acceleration.
Oh, very good. There's a question running through my mind when we were talking was, if you're somebody running 20 ships, so a lot of people will be running, say, IT manager at a tanker company in Athens with 20 ships. They don't really want to get into on this level. I mean, they want to know it's well managed, but they're mainly setting policies, I imagine, aren't they? Which is not looking at individual calls. And do you want to talk a bit about how can they be sure that it's going through the most cost-effective way if you're managing 20 ships at once? Is that something your customers ask you about a lot?
Yeah, so the way we go to market with ZipNet is through partners, right? And those partners typically would have multiple customers. They have a version of what we call the XipLink management system, XMS, in their location, in their NOC, if you will. So they can see the end customer's complete fleet, and they can manage across that fleet and identify for the end user, where all, say, 20 vessels are at one time. So that's an extra layer of management we didn't talk about here, but the partner that is selling ZipNet has that capability, and then they can extend that to the end customer.
Oh, and I mean, I would have thought people would want to see costs while the calls are going through. Is that something that, so instead of saying you're going through Inmarsat, you're going through Starlink, you might say your call has cost 50 cents so far, or I don't know if that's the sort of thing you're.
Well, what we do track, we don't track the individual call costs, if you will, but we do track the data cap usage on each of those systems. So then if you're going over the fixed monthly fee, we can institute our traffic manager and turn it off if that's what the policy is, or keep going, but alert the customer that they're going over their thresholds so that they could take action if they'd like to. So they do have an element of control over the data caps.
Yeah, I just imagine if you're an IT manager, you worry about the captain of the ship saying, "I'm going to send this through the most expensive means," or send it through 3 different networks at once, or
yeah, those things usually happen only once, but
oh. Yeah. So I've got another question from Wei Ho in Melbourne. You're up very late. Do you have terrestrial customers, or are you just shipping customers? I don't know, which of you wants to answer that one? I know you've got aviation customers, whether it's terrestrial or not. I guess it's not, is it? No. Jack, you want to take that one?
Yeah, I'm
Jack,
sorry.
okay.
Yeah, I mean, we have customers in all those verticals, either with traditional XipLink solutions or ZipNet solutions. On ZipNet per se, we're targeting maritime as one of the key markets. So obviously we have some Navy ships on the system. Yeah, and obviously interconnection of terrestrial, satellite, and cellular is one of the key markets here. So any of those vertical markets that need that capability is addressed by this system. But the ones we see at the top of the list, government, which would include maritime and also government mixed terrestrial and satellite services for sure. That's definitely on the radar. Oil and gas is obviously very related to maritime, and that looks like an excellent vertical to go into right now. The NGO service, right, the non-government groups that are typically nonprofit, need a good way to manage their connections, particularly in remote countries that don't have a lot of talent to manage this type of connection. If they can leverage the management capability of ZipNet, then they don't have to worry about that as much. So the NGO community is also a great target here.
I guess there's a lot of people everywhere want more than one communication service at once. I suppose that's how things are going. And, yeah.
Yeah. Or even in the NGO case, they might only have one connection. And but then they want the flexibility to add a second or a different one as the more LEOs come about. And then depending on where they are, they might have one service might be better than another. So even on a single connection, they might look at the capability of this network to leverage their connection with the built-in WAN optimization and QoS controls. In a nutshell, this network kind of makes residential type service like LEOs, certain LEOs, into a commercial enterprise kind of service because we've added all the controls and QoS capability. And you did see one of those graphs that Sasmith showed that showed a more even line across the traffic as opposed to taking big dips and big jumps. And I think everyone on this call probably knows in their customer surveys, they would rather see consistent service than huge jumps and huge losses. So one of the things our network does is actually mitigates the down the downlinks and the uplinks into a more average consistent scenario.
Oh, very good. Well, we've got 15 minutes left. I mean, one topic I think our viewers might be interested in is just advice on the configuration. I mean, you showed those case studies, Sasmith. I think one had Inmarsat as the default for IP or voice over IP, and the other one had, I think it was Eutelsat was the default for voice. I mean, I was kind of thinking, okay, they want the voice to be totally reliable. They want the most reliable service. But the kind of decisions are very complicated, particularly when you've got this sort of IP, what do you call the sensor data that's got to be sent. Plus, you've got Teams calls with the manager. Do you want to give any, what from the discussions you've had with your shipping customers? I mean, I guess everyone makes their own decision at the end of the day, but you must be able to give a lot of useful advice about how these things should be set up. Is there any thoughts you'd like to share about the best way these things can be configured or how to?
Yeah, sure. And one thing I'll mention, go ahead, and I'll mention one thing, and then Sasmith can get into the detail. But you know, we do deliver a default set of settings, right? So when the customer receives the device, they can literally install it in minutes instead of days or hours. That's one of the key benefits of a cloud service. So the default items are there and they're ready to go. And by the way, when the remote device connects to the ZipNet service, it's automatically recognized and all the latest updates are sent out to the edge device. So the end customer really has no work to do in that case. Then they can tweak it using all these different capabilities we have uniquely for them. And yeah, we do have some recommendations, and Sasmith, you can take it from there.
Oh, thanks, Jack. No, I think you covered it best. So we do have, Carl, to answer your question, right? To make it easy, we have a default priorities or default settings for those customers that have not made a decision or have not really analyzed their applications and seen which one is better. So there is a default. And then for those customers that have already gone through this, they know which link is better for which application. And it's not just the performance, right? You got to take into consideration the cost of the links, how much service they have, et cetera, et cetera. And then based on that, they can then, like Jack said, tweak that and ensure that the right priorities are set, the right QoS settings are set. We could restrict, for example, I'll give you an example. If you're file transferring over an Inmarsat, you may want to just send that file transfer. Yeah, just an extreme example, let's say 100 kilobits per second. But when that file transfer switches over to a LEO, you may want that file transfer to go at 50 megabits per second. You can set those QoS settings in the edge device so that as the application switches between the links, the QoS also changes based on whatever priorities they've set. So we have a default, and then we allow them to tweak based on their business case, based on their business requirements, based on their service agreements, etc.
Yeah, we're thinking about, say, vessel performance data. People are thinking about more and more. So they're having a log of your fuel consumption is going to seem to get more and more important. And I guess if there's no link for half a minute and you lose a few bits of data, that could mess it all up. If there's no, I guess it's the sort of thing companies have to think about now, isn't it? And,
yep, absolutely. Operations and vessel operations there, all of that comes into. They're critical stuff, right? In that one example, we showed the IT LAN. That's for operations of the vessel, right? What is the fuel consumption? What speed is the vessel traveling at? All of those things that typical operations team on these vessels are looking at. Right? So,
And crew personal communications, I guess if a seafarer says, I'd love to use video call over Starlink, but I don't want to pay more than the minimum. I guess that's very common sort of thing people asked before, isn't it? Yeah.
Yeah. So, I mean, you can restrict the bandwidth that's assigned to that video call so that the volume of traffic is not used a lot. Yes, they get a lower quality video, but that may be sufficient or may be good enough for them, right? Instead of getting, let's say, a 720 pixel video, you're getting only like 240, maybe good enough, but they're utilizing their volume at lower, controlling the costs, et cetera. So we give them the tools to do that based on what type of service they want or application performance they want.
Oh, very good. So a question from, oh, sorry, Jack.
Yeah, I was going to say, well, there's one other really interesting enabler here when you combine all the bandwidth of all these links and especially the LEO capacities. So you could do, for instance, time of day backups. If you're a maritime operator and there's a certain lower downtime for the crew and the passengers, then you could pick certain hours to do actual backup of the systems where that simply wouldn't be possible over MSS or lower bandwidth links. So they could actually put in their own schedule, or most IT organizations have a time of day scheduler, and they can time the backups from the ship and always have a backup on shore with this technology. And so it's one of those enabler things where it wasn't really capable of doing this before, and now you have enough capacity to do it.
So the ship say I want to send a megabyte a day, but only when Starlink is available. Yeah.
Yeah, exactly.
Right. Yeah.
Right.
So I see we have another question here on firewalls. Absolutely right. You can continue to use your existing security firewalls. That's something that we have paid a lot of attention to because a lot of enterprises or vessels have their own security policies and they have their own firewalls. So yes, that can continue to use those. In case you don't want and you want to use the firewall capability that's built into ZipNet, today we have a basic firewall that allows you to accept, deny traffic or accept drop traffic based on layer 4 classification and then also a certain layer 7 type of classification based on DPI. That's built in. But yes, if you have your own security policy security set up, you can continue to use that. That's not restricted.
Yeah, you must have a very good idea where the communications are coming from on land, if they're coming from the office or from someone who's never communicated before or something like that.
Yeah.
Yeah, this question. Vishal is asking, does ZipNet have any plans to integrate basic features of network management? I guess a shipboard network management. I think you don't, is it? Wi-Fi management and content filtering. I guess that's a different company's job, isn't it? Or is that something you're going to look at?
Yeah, I mean, we do have plans to add some value-added features into the system. We've been looking at some content filtering that are cloud-based content filters that you could build into our cloud system, and then you could turn on as a user. It's not there right now, but we've been researching that, and it is not difficult to add to our cloud service. And that's one way. And then we also are talking to some application partners that deal with things like crew management. They already have portals available with their own solution that deal with all the onboard ship management, crew management, passenger management, all those unique things that are a little bit beyond what ZipNet is. And we're partnering with them that we could kind of share links and share devices and prioritize their traffic. So we could get into more detail and refer you to those partners if need be.
Yeah, something you didn't cover much is the shipboard setup. I mean, if a company is watching and thinking this sounds interesting, but I don't want a big hassle setting things up. I mean, is it literally you're going to send a box by FedEx and they put it on the ship and plug it in and it'll work? Is it that easy?
Yeah,
or?
that's essentially what it is. I mean, yeah, so the assumption is that the links are already in place. So you've already put the Starlink or OneWeb in, you've got a geo operational, you've got probably a cellular data operational. And then you bring our edge device in and basically plug the Ethernet from the modem, from the Starlink modem or geo modem into our device. And we generally recognize what that device is and then have a profile built for that in terms of the link. You don't have to really change anything, on the geo modem side. And It is simply plug in the Ethernet and go. And luckily on most shipboard systems, all those are terminated below deck in a below deck unit in the same common area. So we can take the Ethernet terminations and just plug them in to the ports. On that smaller device you saw, you could directly plug in up to 5 connections. And on the larger device you saw, you can directly plug in to that device up to 9 connections. And then if you want more than that, you can put an Ethernet switch in and go up to 24 links on either of those 2 products.
So if a company did a 1-week trial or month trial, what would success look like? Would you compare the bill afterwards with the bill before, or you'd ask the crew if they felt they were getting a lot more of their calls managed a lot better, or is it what sort of conversations do you have with customers after they've tried it out, do you think?
Yeah, you saw that ZipNet app, and that app is built off what we call probe technology that we've built into this system. And you can actually set the probe to look at before, the optimizations are included and after the optimizations are included. And that's where some of SaaSmith's data came from. And so they can see real live on real time exactly the benefit that the network is giving them. Now that does probably take an IT or the management person on board that vessel, to look at that data and interpret it to some degree, but it's pretty obvious because it's in graphic form. And then of course, the number of phone calls you get, the traditional one, complaining about something or other would be the other one. But you can actually see them before they call with this app.
And for some companies, cost is more important than others. Some companies might care more about the quality of the call, but some cost is absolutely most important part of it, isn't it? I suppose.
Absolutely. Yeah. So when we build these traffic steering rules that SaaSmith talked about, for one company, it might be completely different than another, because one company is very concerned with the cost, and another company might be more concerned with throughput and the lowest possible time it takes to complete an operation.
Oh, very good. Well, we've got about 3 minutes left. I don't know if you want to give a 1 minute what you'd like customers to do, maybe SaaSmith and then Jack. So if people are interested, what would you like them to do next, and how would they get started, do you think?
Jack, do you want to take that over?
Okay.
Yeah.
Because we only have a minute or 2.
Yeah. So first of all, I think many of you know XipLink already, so feel free to, reach out to anybody you know at XipLink. We actually have 2 different websites. Our traditional XipLink website, which talks about our traditional technology, but there's also a ZipNet website. So if you wanted to go to zipnet.com, and all the ZipNet specific items are on that website. There's a link back to the main technology website, but the ZipNet website deals with all the topics we've talked about today and is very focused on this. So if you want to research a little bit more, go to zipnet.com, and then there's a note there if you want deeper information. Just fill out the information form, and we will get in touch with you and help engineer a solution for you. The lead time, by the way, between ordering and receiving the edge device is typically a few weeks at the most, right? You place an order, you receive the edge device from the partner. When you plug it in, the day you go to plug it in, it literally takes, an hour or 2 to plug it in and go and be ready to operate. So we're going down that new tradition that's been established in our marketplace of fast, easy installs versus a long drawn out, got to plan something months and months in advance and take weeks to actually integrate. That's all eliminated with the cloud service.
Oh, well, fantastic. Well, SATCOMs are getting more complicated, but hopefully this is a way to make it easier. So I guess we can finish there. Thank you, Jack, and thank you, SaaSmith, and I shall pass back to Farah for the closing words. Cheers.
Thanks, everybody.
Thank you. Thank you. Thank you for tuning in, and to our guests, Jack Waters and SaaSmith Reddy from XipLink. A video of this recording will be on our YouTube channel, the link sent to you soon. Our next webinar is on the 17th of October with KVH. You can register for this on our website. See you soon.
Bye-bye.
Thank you, everyone.
Bye, everybody.